yesterday's lesson we looked at the first problem involving lockers, okay, which was the midpoint of 2 point, and basically we saw that it traced the same path as the original parabola, okay. So we've got the focus S here, okay, we've got P's and Q's, okay, such that we've got a focal chord, okay, so we've got that focal chord that goes through those 2 points, okay, so if I move one of these points, okay, it always goes through the focus, okay, and likewise, so it's Q depending on P, okay, so we're going to move P around, and the Q value will turn around and turn to Q there. Alright, so we've got the focal chord, so I've got the focus set at 2 units, okay, I've done anyway, somewhere with a slider. Anyway, not important right now. So I've set the slider value for 2 for our conic of x squared equals 4ay. Okay, so I've set that. And we had to get the 2 tangents. And of course, we've got the directrix here at -2. So there's the tangent there, and there's the tangent there. Okay, now no matter where I move that point P, here, the directrix, the intersection of the tangent is always on the directrix. Okay? And that intersection is always 90 degrees. Okay? And we derived that on one of our final proofs on yesterday's lesson. Okay? So I can keep moving that and just keep going along, but the angle of the intersection is always 90 degrees because we have it in the focal chord. If this wasn't in the focal chord, okay, the intersection wouldn't be on the directrix necessarily, and, hang on. Yes, I'm pretty sure the intersection will still be on the directrix, I can check that in a moment, but it won't intersect at 90 degrees. Okay, so from that we had to get the midpoint of the chord PQ. Okay, that was one of the questions we had to do yesterday. There's the midpoint coordinate there. Alright, and then we also had to find the coordinates of the intersection of the tangent. Okay? And we had to show that this was vertical. In other words, parallel to the y-axis. So again, if I move that point P, the line will always stay vertical. Okay, so in other words, the gradient for that line is what? Okay, so the gradient's always infinity. Okay, the last thing we had to do was find the midpoint, the second last thing, the midpoint of MT. So I've labelled it R. And if I put a trace on, we had to show the lockers of that midpoint of MP, which is called R, as the path gets followed. Yep, there we go. As the path of P changes, so that we still have a focal chord, the path of the midpoint of the intersection of the tangent, and the midpoints of the chord will trace out a parabola of the original form. Okay? Right the way through. So if I change that to focal length 3, for example, okay, remove that locus traces the original parabola x squared equals 12y.
If it's a focus, no, it won't.
Okay.
No, it can't.
Talk there.
If it's a focal chord, no, it's a silly question. If it's a focal chord, will that always be on the parabola? The midpoint?
This particular style of example, yes. Okay? Yeah. Okay, but you also got to consider the question will ask you about the locus of the midpoint, the locus of the midpoint of PQ, the capital M. So if I put a trace on this one, okay, and then we got the trace of that, that will form a parabola of a different form. Okay, so we have to solve our x's and y's, eliminating the parameter, and we will have another parabola. Okay, with the vertex at the focus. Right, so that'll be, I'm sure there'll be a question along those lines coming in to do the midpoint of the chord PQ. Okay. So that will work for any value. Okay, so of course if I change this to, let's go a negative 2. Okay, so everything's flipped over. Alright, so we got the parabola x squared equals negative 8y for the focal length 2. Okay, so I've got my p's and q's still going to the points of the focus. Okay, so now we've got it negative a for the focus and y equals a for the directrix. Okay, now because it's negative a, because that's what I've set in the formula, but a is negative 2, so that makes it a positive 2 here. Okay, now if I move that point P around like that, the R, the midpoint of MT, will follow the parabola of the original form. And it still intersects at right angles on the directrix as I move that point around the parabola. Yes. One of my favourite toys because it does do well in showing locus style questions. You can pass out your point. Okay, so we can maybe spend a lesson setting up a file and using it to help you with your question in the course. But any further questions on that? So does that help make more sense?
Yeah.
To what we were doing yesterday?
See it, so
yes, and that's and then when I found out Michaela wasn't going to be here this morning, I was like, oh, I did this for you. But I'll trace out what we'll do today is we'll go through the final 2 questions. Okay, and then I'll set up a file and show it to you guys. So you can visually see what's going on. Okay, I might even set up a file for all your questions in the extension for your locus. That way you can get the file, you can see what's happening, and then you have to work out the equation by deriving them. That'd be good because my wife and son's going away for a week, so I'm sure I'll be a bit bored not them being at home. So I'll have plenty of time. So I reckon I'll sit down and try to do some questions and map it out for you. But you both have iPads, don't you?
Yep.
So you'll be able to download GeoGebra on that, okay? And then I'll be able to probably just email you a file. You'll just open them on your iPad, and you can play with it with your fingers, whatever. How long you want to play for, and get that understanding. Okay. Right. So we've answered that question. That was the diagram for that particular question. Right. So up to B in further properties and looking at examples. Okay. On page 110. No. Right. So, 2 point P, QAP, AP squared, and Q, QAQ, AQ squared, lie on the parabola h squared equals 4ay, PQ passes through the focus S. Alright? So, when we do a locus question, you read through the whole question, so you've got an idea of where you need to go get to at the end. Okay? So first we need to prove that, can you cross out the capital PQ? Should be a lowercase pq. Prove that PQ equals -1. So in B part I, Michaela, just cross out capital PQ and change that to a lowercase pq. Lowercase pq equals -1. Part 2, show that the point of intersection of the tangent, P and Q, lie on the line y equals negative a. Okay, and then we need to show that the path PQ, so the 2 points, okay, on the parabola there, that goes through the focus, so we've got that focal chord. We need to prove that the equation of that focal chord is given by that in your answer, a outside of p plus 1 plus p, 1 over p, all squared. Right. So, now that we read through the question, we now go back to the start. Alright? What's the first thing I need to do to answer this question? The very first thing for all questions. Right, so even if it's a rough sketch, how big is our diagram going to be? About a third of the page, alright? Nice and big. Because once you are answering parts of your question, it'll be much more efficient and much more quicker to be able to go back to your original diagram, okay, and read that information on there. So in terms of answering these questions in your exams, I would probably draw the diagram into a separate book, so that it's always in front of you, so you don't have to keep turning back and forward pages. Okay, into a separate book, you'll just label it 2 separate books, so I've seen you draw a diagram, and then in your second book, you will answer the question while still looking at your diagram. Okay, that's my recommendation. Okay, so we have the parabola h squared equals 4ay. We have the point P and Q, which passes through the focus S. So we have the focus S at 0, A. Okay, we'll keep it as accurate as we can. But remember, this is a sketch. You're not getting marked on your sketch unless the question asks you to draw a sketch. Okay? And it's allocated marks there. Yep, so we've got S squared 4ay. We have PQ, which goes through the focus. And that's all the information we're given so far. Alright, so the first steps we need to do is prove that PQ equals -1. Okay, so RTP required to prove PQ is -1. Right, how am I going to do that? Find the gradient of? Where did this result come from? I've been told you told you to remember it, but you also need to know how it works, where it comes from. So doesn't say anything about tangent so far, doesn't it? What? Okay. What information from the diagram can I obtain? With the information given to me in the diagram, what could I do with it? Well, we've talked about, what is the question? Read the question again. Read me the question.
2 points, P2AP AP squared and Q2AQ AP squared lie on the parabola x squared equals 4ay. PQ passes through the focus S.
So PQ is a focal chord. So that's the suggestion in the question. Let's start. Yeah, let's now start working on the focal chord. What we're going to do, we can find the equation of the focal chord. Okay, we're given 2 points. Okay. Or technically, we know it goes through this one. Okay, so we could even go the equation of PS, and that will give us the information we need for the equation of the focal chord. So previously, we have found the gradient using these two, okay, and then substitute into the point formula and then substitute this into the equation, okay. How about we give it a go? We find the equation of PS. So we're eliminating that, goes back to here, and we're making the substitution from the very start. Right, we'll give it a go. Right, so the gradient of PS going to be a p squared take away a over 2ap take away 0. Okay, so there's my gradient. I wonder if this will work. We'll find out. So if y take y1 is m, take x1. It'll work eventually. Let's use I guess it doesn't really matter. Y take away 0, you look at p squared take away 1, outside of x take away a, over 2p. So 2py is going to be p squared x take away a, p squared take away x plus a. No, it won't work. Unless we substitute in q, we'll need pq. You know what, that's going to get more messy, I think, before it gets more better. Alright, let's start again. So gradient pq, ap squared take away aq squared over 2ap take away 2aq, a p take away q, p plus q over 2a p take away q, p plus q over 2. Yeah, you might need to put another line or two in there. To get that. Alright, so now it goes through the focus. So at 0, a is going to be p plus q over 2, lots of 0, take away 2a p q. Oh, hang on. That shouldn't be there because I'm dividing everything by 2. Eliminate the 2 out the front. So a equals negative apq, therefore pq is negative 1. Okay, so that's one important result to know, but you need to know how to derive it as well. particularly with this question, when it says prove that PQ equals -1. Show that the point of intersection of the tangent at P and Q lie on the line y equals -a. Okay, so how am I going to do that? Thinking about it. The intersection of the tangent. Point of intersection of tangent at P and Q lie on the parabola on the line y equals -a.
Find the equation of the two tangents, and then simultaneously solve to do it.
Say it again, sorry?
Then solve them simultaneously to get the
Yep.
thing.
Okay, so that's y equals -a. So now we are proving okay, so it's not a well drawn diagram, but that intersection is on the tangent, on the line y equals -a. So I probably should have done the intersection of the two tangents there and then put the line through it, the horizontal line. That probably would have been a better approach. A good thing we're not getting marked in our diagram.
I wasn't even close.
Yep. Okay, so probably in future you do the tangent there and then the horizontal line through it. Okay, so as we're getting through the information, we are adding it to our diagram. So I've added the two tangents and I've added the line y equals -a. Alright, do you remember what the gradients of the tangents are is at P? Capital P, we have, so the gradient of tangent at P is P. Alright, now, this question has not asked you to show the equation of the tangent, it's asking you to show the intersection of the tangent, okay? So that means you can assume this. Alright, so y take away AP squared is equal to P outside of X take away 2AP. Okay, I don't remember the equation of the tangent, but I can derive it quickly. So y take away AP squared is equal to PX minus 2AP squared. So y is going to be PX take away AP squared. Okay, equation 1. And similarly, at capital Q, so we're not going to go through all that work again. If I can match, if I can recognise my pattern, okay, so y is going to be Q X take away A Q squared. Okay, so we need to solve them simultaneously. Okay, so what would you do?
I would PX take away AP squared equals 2X take away AP squared.
Say it again, sir.
I'll just replace the y. I just put it into the equation.
But you're solving for x, aren't you?
Yeah.
But we want to prove that it intersects y value at -a. So I need to solve these two equations for y, not x. Okay? Because you can do what you've done, but you have to do x first and then y. Okay? But if I can find a way I can get y without having to do the x, okay, I could save myself that time.
Would you...
So how am I going to eliminate these two to get these two subjects? Well, these two need to be the same, so I can do the elimination method. Is that right?
Yep.
So if I times this by Q,
Yep.
and times this by P. Now I've got the same variable, I can now do the elimination method. Right, so Q take away P, lots of Y, so I'm factorising that already. Going to equal negative APQ outside of P plus Q. Yes? So I've essentially done the subtraction, but I've also incorporated the factorisation. Okay, this is what I do, but until you're confident, you need to put the middle steps in there. Right? So Y is going to be negative APQ, P plus Q over Q take away P. Any idea where I'll go from here? Thinking about your end result. That's what we need. So we need to somehow get rid of everything else there. How am I going to do that? Okay.
Yep, there it is. Would it be negative out of P plus B?
Because I factorise the negative out.
Yeah, then it'd be positive, wouldn't it? Because you factorise the negative out, but you didn't change the sign in the Q and the P.
Well,
Oh wait, no, you swapped. What am I talking about?
swap them around. Okay, and I can also go APQ.
Yeah, go to P.
Negative. So I've taken a negative out of here. To leave the plus. Got that right. That, take away that. That. Because that take away a negative that make this positive.
Yeah.
But when I factorise the negative out, to get it back to a positive, I need to put a negative back in here. Okay, so maybe I should have done that middle step. But I could see something wrong and I can actually see where I've got it wrong. P, so I don't need to read about that line. Okay, so, yeah, cancel. Equals A, P, Q. Just about there. And what do I need to do to finish it?
P, Q equals -1.
So, but P, Q equals -1. So if you could not derive it from the very first question, you can still use result to finish that particular question. So Y equals -A. So, yep, over there. You're asked to show, not to prove. Well, you essentially are proving.
We
But
restate it or not.
probably should. Therefore, tangent intersect. As far as I'm concerned, I showed it. Showed that y equals negative a, essentially what you're doing. Okay, but yeah, probably a good idea to finish that proof. Alright, part 3. Now we're showing the locus. Show that PQ. So required to prove that PQ is A outside of 1, P, plus 1 over P, all squared. So we still have parameters involved here. So we're not actually showing a locus, we're just showing the equation of the chord, PQ, into that format. So we're going from this to this. So this one, if you're not sure where to go, you need to think about your midpoints, the formulas, your distance formulas, and equation formula. The gradient formula won't help you. Distance and midpoint formulas at this point you're thinking about now. Okay, so I'm going to use the distance formula for this one. So X, reminder what it is. Okay. Now, remember if I square both sides, I'll get rid of that third. That's actually what I want to do straight away. And I'm going to represent the distance PQ. Okay, so this will become PQ squared is equal to 2AP take away 2AQ all squared plus AP squared take away AQ squared all squared. Okay. My instrument pump. Right, so some shortcuts in your mathematics into extension 1. Okay. Now we can go ahead and do this a long way, or we can try to identify the pattern of the quicker methods. Right, so we can see this term here, we had the common factor 2a. Right, so let's factorise that out. Now, because there's a square outside the front of the bracket, it means there also needs to be a square here. And what's left is P take away Q, all squared. Plus, common factor here is just A. And because the whole thing's already with a square, we take the A and it'll be a square out the front. That's the shortcut of your index laws. So 4a squared P, if I haven't expanded that yet, P take away 2 squared plus A squared P take away Q squared P plus Q squared. Okay, using your index laws. Alright, so there's the plus, there's a whole term here, and here's another whole term here. Okay, what's the common factors with those two terms? And? Okay, so that equals A squared, P take away Q, all squared, outside of 4, plus the P plus Q all squared. Yep. Alright. So, any ideas where to go from here? What does this have that this... So what does this does not have that this has? So we have to find a way to eliminate Q, don't we? Alright, how could I do that? Thinking about what I've already done, what could I do to eliminate it? Yeah, like what? Hey? Do we have PQ?
Yeah.
Which is? So, what's Q then?
Yeah.
Okay, so we know PQ is -1, and from that we have to imply that Q is -1 on P. Okay, so equals A squared, P take away Q all squared. I'm not going to substitute the Q value in just yet because we need to want to expand this first. Outside of 4 plus P squared plus 2PQ plus Q squared. PQ is? Right. Any ideas how to factorise what's in the square bracket? So?
That one.
Square brackets, yes?
Perfect. It's a P plus 1 is P.
Say it again. Say it again.
P plus 1 is P. So it's a perfect square.
This is in the form A squared plus 2AB plus B squared. Okay, so we multiply these two terms together, we'll get 1, including the square, and we double it. So this factorises to a perfect square for us. Same base, we can add our powers. So always going back to the original question and checking that you've answered it. Have we? No. So what's the final thing we need to do?
Take the square root.
Yeah, because this is all P's Q all squared. Alright, so therefore PQ is A outside of P plus 1 on P all squared. And we can do that because we now have the product of two terms. Okay, we can then take the square root. If this were the addition of two terms, we could not do this. Okay, that's why I had to factorise. Probably should have said that at the start. That's why we were factorising.
That's a good chunk of P's and Q's.
Hey?
So many P's and Q's.
Yes. And plenty more coming in your exercises. Okay, any questions on that one? So we've just represented that vocal cord in terms of the parameters P. No keys involved at all. Okay, and that's why the questions are broken up into three parts like that. Okay, just because we needed that first part to answer the final part. I'm not going to ask you at the very end to show that PQ equals A outside of P plus 1 over P all squared. Okay, you had to give you a couple of lead-up questions so that you can get yourself going. Alright. Alright, part C. P. 2A T. Sorry, I'll do it again from this side. Alright, C. So we've got P, which is 2AT, AT squared. So sometimes they will mix that up like that a bit. Alright, lines on the parabola, either point, sorry, on the parabola, S squared equals 4AY. Right, so reading through the whole question before we start answering part I. So prove that the equation of the normal at P is given by that. This normal meets the y-axis at Q. Find the coordinates of Q. Find the point M, which divide PQ externally in the ratio 3 to 1, sorry. And hence find the equation, the Cartesian equation of the locus of M. Okay, so that external point of the intersection from the tangent, okay, find that external point either here or here, externally in the ratio 3 to 1, and find the path that that point moves by eliminating the parameters. Okay? Right, so let's start answering. So prove that the equation of the normal at P is given by that. So, we've got the tangent. What's the condition for the normal? Perpendicular. Okay, we've got that intersection, which is Q. In terms of my diagram, of course, we can put P anywhere, and that could change where the diagram is, but the normal should always be in the positive y-axis because of the format of the parabola. Okay, so I. So what is the gradient of the tangent? In this case?
T.
Okay, so gradient of tangent is T. Okay, so remember we can't do that, we have to go through calculus and derive it. Okay, so the perpendicular gradient is going to be -1 on T. So we now need to find the equation of the normal at P. And we'll write it in the format of our notes. So x plus 2y is equal to 2at plus. Okay. This normal meets the y-axis at Q. We need to now find the coordinates of Q. How am I going to do that? Seriously, think about it. What can you tell me about the coordinates of Q?
X equals 0.
And that is why our diagrams are nice and big. Okay, so you can get all that information in. I'll quickly reference the diagram and I'll have to redo my working. Alright, so if you wanted to write t squared plus 2 because you're used to the format of a polynomial, that's fine. Okay, if that annoys you, you can do that. Right. Find the point M which divides PQ externally in the ratio 3 to 1. Okay, so externally, so we've got the interval PQ. We need to divide it into 4 equal parts, essentially, and find M out here or up here. Okay, so in a sense what we're doing, we're finding either M1 or M2 because it's outside the interval. Alright, now because there's nothing in the question to suggest either way, okay, you pick one of them. Yeah. Well, I'm not going to ask you to find the Cartesian equation of the locus of M, aren't I? And do both. Alright? Now, thinking about this, let's write your coordinate. We've got P, which is 2at, at squared, and we have Q, which is 0, a outside of 2 plus t squared, and the interval is 3 to 1. The ratio, sorry. Now, for it to be an external ratio, how do I need to change this question?
Make one negative.
Which one are you going to make negative?
-1.
Good. Why?
Because it's simple.
Hey?
Because it's easy.
Well, it will reduce the need for negative numbers. Okay? So if I unless I need them, I'm going to try and avoid them. Right, so do you remember the process? Ready?
Oh, yeah.
Yep, do that first every single time. That will get you correct every single time. So it would be mx2 plus nx1 over m plus n, and y equals my2 plus n y1 over m plus n. Okay, so that times this side, and this side times that side. So x equals 3 times 0, take away 1 times 2at, because of the negative sign, over 3 take away 1. So negative 2at over 2, so negative at. Really? Okay,
What happened?
what happened? This is negative AT. This is 2AT. This is...
It's actually
Oh, so we're finding this point here. Sorry, yep, x-axis. So we're finding M2. Okay, now if we put the minus sign in front of the 3, we'd find M1, wouldn't we? Now I think logically, most people would do this process because they would see it as a 3 take away 1, not a 1 take away 3. Alright, but this should work, okay? So you're going to get the similar sort of equation of the locus, but it all depends on how that moves. Alright, so y is, so this left side of the ratio times the right coordinate, and the right side of the ratio times the left coordinate for your x's and y's. Alright, so 3 times a outside 2 plus t squared minus 1 times at squared all over 3 take away 1. So 3a, I'm not going to expand it just yet until I see what's happening. And now, because I've got 3a times t squared, take away at squared, now I'm going to expand to tidy that up a bit. So 6a plus 3at squared minus at squared all over 2. Alright, so 6a plus 2at squared all over 2 is going to be equal to 3a plus at squared, a outside of 3 plus t squared. Okay? Therefore, m is negative at squared and a outside of 3 plus t squared. Alright, and then corresponding with your diagram, negative at squared is going to be on this side, isn't it?
Is that AT?
So?
Just AT, not AT.
So, yep. Alright, so negative at and a outside of 3 plus t squared. Which makes sense because we're going to be 1 unit higher than this one. Because of the 2, this is going to be higher here. Okay, so I haven't found that one, I've found that one. Okay, but unless you're given specific information about which side, you need to stop there. Well, you've no point in going any further, you're not going to get yourself more marks. And hence prove, I find the Cartesian equation. The Cartesian equation has no parameters, so we need to eliminate the parameters. Okay, so from your midpoint, the x value is negative at, and your y value is a outside of 3 plus t squared. There's my two parametric equation. We now need to solve one of them for t. Eliminate that parameter and substitute it into the other one. Okay, which one am I going to solve for t? Good. So t is going to be x, negative x on a. So equation 1, equation 2. So equation 1 into equation 2. So y is going to be a outside of 3 plus a negative x on a, all squared. Should be finished for alcohol. Alright, so a outside of 3 plus x squared on a squared. Okay, let's expand it out. 3a plus x squared a on a squared. So we're going to get x squared plus 3a. Oh, sorry, x squared over a plus 3a. And what's that path?
That is linear path.
What path is this trait?
After the focus. No. The. I'm not sure. Wait, what do you mean?
Isn't that what it is?
Yeah.
So what path is it?
It's a parabola.
Yes. This is the parabola that cuts the y-axis at 3a.
Okay.
Right, so somewhere up here, it cuts the y-axis, and it's going to be a parabola going something like that. Right, with the coefficient out the front, 1 over a. 1 over a x squared plus 3a. Okay, so we eliminated the parameter. Remember, a's are your constants, constant length, because they're the focal length. Okay, so that's all I can do. We eliminated the t parameters. We've eliminated parameters and got it into a Cartesian. Right, so I'll work on a diagram of all this for you so we can make sense of what's happening.
Yep.
Right, but we need to recognise that this traces out the path of a parabola.
Okay.
Okay, so now that's the topic done. Exercise, the rest of chapter 11, so that's now exercise 11.9 and 11.10. Okay, so I've covered all the theory for those two exercises over the last 3 lessons. Okay, so now you're going to get some work done, and I think we're going to have to move on next week so we can get the course done ready for your prelim exams.
How many more weeks do we have?
This is week 5. Your prelims start week 9. You have 4. Week 6, 7 and 8. So 6 lessons to get through about 6 lessons worth. That means you're going to have to do a lot of work outside of class time.